All right, hi physical science. This is your introduction to waves. So, lesson one on waves. Get something to write with. You're going to want to take some notes. We're going to talk about a couple different things like the different kinds of waves. We're going to talk about different parts of a wave and some basic stuff like that. All right, so here we go. So, first off, what is a wave? You might be thinking of a lot of different things when you're thinking of a wave. You could think of like someone waving. You could think of like the waves at a beach, like waves in water. You could think of like light waves. You could think of a picture something similar to this with like this squiggly thing. There's a lot of different things you can think about, but basically, our definition of a wave, it's a kind of oscillation or disturbance that travels through space and or matter. So a wave transfers energy from one place to another. So that's going to be our definition. That's the big one. Waves transfer energy from one place to another place. So let's talk about a couple different parts of a wave. So we'll start here with number one. And we've got this line that is curving back and forth. This is going to represent our wave. Now we've got this high point over here, and we are going to go all the way across to the next high point. This distance, this is going to be called our wavelength. So wavelength would be like the high point of this wave to the high point of the next wave. And it's how long before the wave starts repeating itself. Sometimes it's represented with this little lambda symbol. So you'll see that sometimes. If you see that, it means wavelength. So this second part down here is the trough. This is the lowest part of the wave. So this is the most bottom part of where the line curves down. We're going to skip 3 for a second. We're going to go over here to 4. And number 4 is the crest. The crest is the highest point of the wave. So the highest point of the wave is the crest. The lowest point of the wave is the trough. Now, number 3, we're going to go from the middle line up to the very top, and this distance is called the amplitude. Now, the amplitude is also the middle line down to the lowest point. That point, those should be equal, but the amplitude would be the middle up to the very top. Okay, so now we're going to talk about a couple different types of waves. So we're going to have 2 types of waves. We're going to have mechanical waves, and we're going to have electromagnetic waves. So starting with mechanical waves, these require a medium or something to move through. There has to be something that these waves move through, otherwise they wouldn't move. Now, we have 2 different kinds of mechanical waves. The first is called longitudinal waves, and the next is transverse waves. We'll talk more about these in the next slide. But important to remember, mechanical waves, they need something to move through. That something is called the medium. That could be air, that could be a solid, that could be liquid, but these waves need to propagate through something. Now, electromagnetic waves, they do not require a medium to propagate. They're what's called self-propagating. They can move forward without having to move through anything. And there's various different types of these. We'll talk about these in a little bit, but they all are going to exist on the electromagnetic spectrum. So mechanical waves. Again, we have the 2 different kinds. We have longitudinal waves and transverse waves. Now, longitudinal waves are compressional waves. An example of that would be sound. Like if me and you are standing in a room and I begin to speak and I'm making noise with my face, and sound is coming out of my mouth. Now, that sound will move through the air between me and you. The reason that you can hear me is because there is air between me and you, and it compresses the sound that I'm making will actually compress parts of the air and move forward towards you. You will then hear that sound because the wave moves through the air, and you will register, it'll send a message to your brain registering that as sound. Now, longitudinal wave an example we would use is like in a slinky. If you like take a slinky and you like push it instead of, moving it like a rope or something like that, if you just give it a little push, you'll have a little part that's compressed. Now, this is an example of a longitudinal wave. It would move forward through the slinky, and here it says moves in this direction. And one part would be more compressed than another part. That's like the air between me and you, and the sound would be compressing parts of the air, making that part of the air literally a little bit thicker than the next part. And that's how sound would move through the air. That means if we were to suck out all of the air in a room, you wouldn't be able to hear anything. You wouldn't be able to hear the person in front of you talking because the sound would have nothing to move through. There would be no medium for the wave to propagate through. Now we'll talk about transverse waves. This is typically what you would think of a wave as, like at the beach. Now, when I think of waves and someone says waves, I think of waves at the beach. An example, like I said, water waves. That would be like if someone took the slinky and they did this. They had this end attached and they were just moving this end up and down very quickly. Well, these loops or this hoop right here, this hump would move forward, and as she kept moving the slinky up and down. This is how water waves work. And that's like the typical wave that you would probably think of. So that is a transverse wave. The medium moving up and down as opposed to left and right. Okay, so electromagnetic waves. So this is the big one, electromagnetic spectrum. This is a huge, huge spectrum that exists, and we use it for all different kinds of things. It's super important to our everyday life and what we do. We're going to start with the first one, visible light. Visible light exists on the electromagnetic spectrum. It's what's responsible for us seeing stuff, and it's actually just a tiny, tiny part of the electromagnetic spectrum. It's very small. And this certain wavelength of light will hit things. That light will bounce off that thing, come and hit you in the eye. And you have little receptors in your eye that are triggered by that wavelength of light. That sends a message to your brain, giving you color. Now, again, visible light is just only one part of the electromagnetic spectrum. There's a bunch of other parts like microwaves, infrared, X-rays, ultraviolet, radio waves, and they're all really, really similar, but their wavelength differs. And that's what will determine like how much energy that they have. Now, radio waves down here on the end, they have a very long wavelength. They're going to be very long wavelength, and as we move forward, you can see that we get to microwaves, we'll have shorter wavelength. Infrared will have less. Here's visible light. Visible light's about in the middle, and this is the light that we will use to see, the light that our eyes register. We keep moving forward, you get a shorter and shorter wavelength. And we'll end up all the way down here in gamma rays. And the only difference between any of these is their wavelength. It'll tell, and it will determine how much energy that wave has. So to recap here, waves. We have mechanical waves. These require a medium to move through. That means there has to be something that the wave propagates through. Longitudinal waves, that's where that medium will move left and right, like sound. It would be a compressional wave. We're literally compressing part of that medium as it moves through the air or moves through whatever it's moving through. Transverse waves would be where the medium will move up and down. That's like water waves. Now, the electromagnetic spectrum does not require a medium. It can move through the vacuum of space without having to move through anything. And that has a variety of different kinds of waves like light, micro, infrared, X-rays, ultraviolet rays, and radio waves. So knowing the difference between these kind of waves is going to be important. You're also going to need to know the different parts of a wave. Okay, so this is your introduction to waves. Please check Google Classroom for your assignment. There's going to be one posted on Monday. Make sure you get those done. Make sure you guys take good notes. If you have questions, please email or join office hours. Those are both good. But yeah, let us know if you have any questions. And thanks, guys. This has been your introduction to waves.